Hello, my name is Yuda Handelsman. I'm an endocrinologist in private practice and the medical director, principal investigator of the Metabolic Institute of America. Today, I'd like to open the presentation on the program on pathophysiology of type 2 diabetes, mechanisms of disease. When we're looking at type 2 diabetes, it's quite a complex disease, and recently we recognized that really it encompasses every aspect of the body. And this has been put together into a concept called the ominous octet, where we are looking at the disease and its development through different parts of the body that we term the ominous octet. Today, I'll introduce to you the first of the module, where we're looking at the beta cell. When addressing the ominous octet, we're actually looking at 8 different aspects of body's metabolism. I will focus today on the beta cell and insulin production. The other modules would look at the alpha cells, which produce glucagon, the intestines, with production of GLP-1, GIP, and perhaps other hormones. We are looking at fat cells, and we are looking at uptake of insulin-free fatty acids and effect on insulin resistance, looking at muscles, and looking at uptake of glucose into the muscles or the development of insulin resistance relating to these uptakes. Obviously, the brain takes a very important role in this whole discussion of metabolism and the development of type 2 diabetes and its worsening, if you will, progression over time. Clearly, a very important organ is the kidney, which is very important in reabsorption of glucose as well as in producing glucose, not unlike the liver, which is also very important in gluconeogenesis and glycolysis. All of these which are being affected both by insulin resistance and perhaps not enough insulin being produced from the beta cell. That is the module that we are going to start on today, and I do invite you to download the rest of the slides with all the modules over time. So we are going again, as I said, looking today at the issue of insulin secretion from the beta cell. And at the end of the day, this is what determines the development and progression of diabetes. It is this lack of insulin that is not out there enough to cover the needs to address glucose and carbohydrates in the body, perhaps fat and other energy aspect of metabolism. It's that lack of insulin that will eventually determine the development of diabetes. So when we're looking at the natural history of diabetes, what we're typically seeing that many years before diabetes development, we don't see any changes in hyperglycemia. However, as over time, as insulin resistance increases, perhaps by natural genetics, heritage, but mostly with lifestyle development of obesity and inactivity, we're seeing quite an increase with insulin resistance. The beta cells respond accordingly, and we are going to see an increase in insulin production from the beta cell. There will be a point there at a certain time there will be too much insulin produced, and yet it will not be enough to overcome the high glucose. And that's when diabetes starts developing, when the glucose numbers start rising. At times we'll see first the prandial. After a meal, we're going to see the glucose rise, and only later we may see the fasting glucose. Those are some people where the insulin production starts failing. But at the end of the day, once we reach a height of insulin production and at the max that the pancreas can produce, at that point there's going to be failing less and less insulin, higher and higher glucose level, and that determines the level and the stage of diabetes. So when we follow again, you can see now on this slide very clearly that early on whether it is a lean person or obese person. In the early stages, we don't see an elevation of glucose. What we are seeing is perhaps at a certain point, in particularly in the obese person, that there is an increase in insulin production. And that increase in insulin production continues. Glucose then starts slowly to rise up. At a certain point, the insulin goes down, glucose keeps going up, and we are going to see the progression from normal glucose into impaired glucose level into eventually type 2 diabetes. Actually, we will see also type 1, but the process is a bit differently. Concept is the same though. Not enough insulin to overcome the need to put the glucose into the needed cells. What we are seeing here is a very important concept, that by the time a person already has just glucose of 140, this is what we call impaired glucose tolerance when we are looking at prandial glucose. Obviously, impaired fasting glucose ranges from 100 to 125 milligram to deciliter. But when we are looking at impaired glucose tolerance, 140 to 199, just by the 140, already at that point, we are seeing a reduction of the beta cells on average of about 50%. So beta cell mass failure down to about 50%, either by function or by the mass itself. It's not always that clear, but the total product is what's important. We have not enough insulin to overcome this glucose. By the time diabetes develops, fasting glucose 126 or above milligram to deciliter, or post-stimulation 200 milligram to deciliter, we are seeing anywhere from 70 to 80% reduction in the ability of the beta cell to produce insulin, and with it quite a reduction in beta cell mass. As the diabetes develops and progresses, the beta cells start being unable to produce enough insulin to overcome the need to use the glucose into the energy part of metabolism. And as disease progresses, less and less insulin is available, and therefore more and more glucose is going up. So we are seeing the development of diabetes, and we're seeing the progression of diabetes. Therefore, it is critical in the whole understanding of this concept of diabetes to recognize that there are many aspects that are controlling the appearance of glucose in the body, but it is the inability of the beta cell to produce enough insulin to overcome that glucose, the inability to overcome the insulin resistance that eventually leads to diabetes and its progression. To try to be able to assess the functions, people have done insulin clamps, and they try to see how much insulin is produced and what is the glucose level and how does the beta cell functions, until they develop a concept called the insulin disposition. In that disposition, we are actually looking at the level of insulin and the response of glucose to insulin in that ratio. And we put it in the formula, and by using the disposition, we're able to look at how much insulin is available, how active is the available insulin to address a certain level of glucose. Not too complicated, though it sounds complicated, but using the insulin disposition really allowed us to be able to assess the level of function that the beta cell still has when we are managing the person with diabetes. In fact, what we can also do is assess different treatment parameters, different medications, and see how do they affect the insulin disposition, and to see how can we control diabetes better over time. What you're seeing actually in this very slide, it's quite a nice pictorial representation of what happens to the beta cell and its failure. And you can see how a person moves from the amount of beta cells from normal glucose to impaired glucose tolerance to eventually beta cell failure and to reduction in the amount of available beta cells and available mass to produce the needed insulin for the practicality of controlling glucose in the body. Through the discussion of the mechanism and pathophysiology of diabetes, obviously we'll also address potential management. And as you go to the different part of the ominous octet and the different organs, you will hear about different types of medication that may address that particular organ, whether it is fat cells or insulin resistance or perhaps kidney, and all the various options that we have. When we are looking particularly at the beta cell, there are several medications that we can look that affect the beta cell. We've got medication like glimepiride or sulfonylurea. That glimepiride is a type of sulfonylurea. There are others over there. There are glinides, which are short-acting sulfonylureas, if you will. And basically what those drugs are doing, they go to the beta cells, they press on a button, if you will, and they cause production of insulin, kind of squeezing the beta cells as much as they can. They were okay. We've been using them over the years. They're somewhat inexpensive, or very inexpensive, if you will. The problem that they have is that because they're squeezing the beta cell, over time the efficacy kind of wanes away. In the last few years, we were introduced to the incretin systems, and the incretin systems introduced two types of medication. One were the DPP-4 inhibitors. The DPP-4 inhibitors actually allow the incretin coming from the intestines, which you will hear again on a different module talking about the intestines, but they allow them to improve the function of insulin production from the islet cell. And the other one were the GLP-1 receptor agonists. Those medications that pharmacologically have a huge effect on the incretin receptors, further work allowing the islet cell to produce better insulin. So we believe that the GLP-1 and the GLP-1 and GAP hormones improve insulin production, perhaps improve insulin function as well. And it would be interesting to see how those medications are able to affect the beta cell over long term. So as I just mentioned, the TZDs, and we know that the TZDs improve insulin resistance, and the TZDs may have a good long-term effect on the islet cells, has been done and shown by several studies. Metformin is a drug that improves insulin sensitivity. It's not a typical improvement on insulin resistance. I know it's a tough differentiation, but at least in rodent, what we are saying is that utilizing metformin did improve, perhaps through its effect on incretins, did improve the disposition index. I am not so sure that it was translated in humans, but at least it has an interesting promise. So to summarize shortly what I talked about is, I pointed out that really what defines diabetes is the failure of the beta cell to produce insulin in the background of insulin resistance, and this is progressing over time. Medication like the TZDs and the incretin-based therapy like DPP-4 inhibitors and GLP-1 receptor agonists actually seem to improve beta cell function even over time. Metformin too seemed to be able to improve the ability of the beta cell to produce insulin, perhaps through its effect on incretin, on GLP-1, has been shown in animal studies. I hope that I was able to introduce the pathophysiology of type 2 diabetes to you, in particularly highlight the role of beta cell failure and reduction in insulin secretion as the main part of the pathophysiology of diabetes, in particularly in view of insulin resistance. If you'd like to learn further on the role of the other aspects of the ominous octet, you're invited to download this slide set where you will get further discussion on the various aspects of the pathophysiology of diabetes as it is being presented by the various part of the ominous octet.